Okay, can we start the timer, please? Let's get going. Thank you very much. Okay, thank you for coming to this session. I realize that this is the first session after the big night out. I hope you enjoyed yourself. Unfortunately, I didn't make it myself. I was sequestered in my hotel room doing a presentation. But those are the sacrifices that we gladly make. So my name is Peter Willitsen. I'm a program manager for Microsoft. My charter is the development experience of Dynamics AX. So my team builds the user experience for developers. We are charged with all the Visual Studio work, with the compiler, debugger, best practice rules, a lot of ad hoc tools, and so on. That's what my team owns, and I'm the PM for that. So we're going to be talking about several things today. I'm going to start with the developer experience. I'm going to do a lot of demos along the way. And I'm going to end with a little nuggets of advice that I have collected over a long time. I know I see some seasoned guys who have been in this industry for a long time, and maybe I'll reach out to them to confirm some of my advice, or maybe they can contribute some advice of their own. We'll see how that goes. Oops. Come on. There. Okay, let me start out by describing some of the characteristics of what we do in AX development. So AX applications that you send to your customers are really typically mission critical. Often you will find that if your system breaks or your system goes down, your business can't do work. And every time it can't do work, they're losing money. So there is a mission critical aspect to development here that is pervasive. It's not like building a Windows Phone app where there's always 10 other apps that you can use instead. No, that's not the case. You're building something very targeted, and it's always mission critical. Also, development in AX is complex. I'm not going to sugarcoat it. I'm not going to say that it's easy. I'm not going to say that it's just dragging and dropping a few boxes and putting a few lines between them. That's not at all what it's like. When you're developing a solution for AX, excuse me, you really need to understand the problem space that you're trying to solve. You can't just give, in my opinion, you can't just give a developer a piece of paper with a spec and say, do this. If you don't understand the problem space, you don't have a chance. It doesn't work. There is an amount of knowledge that you need your hardcore developers to have to solve a particular problem in your problem space, which is interesting. I wish I had a clicker here, but I don't. So for all AX development throughout the time that we've had this is the formula that accurately describes what we do. Does anyone recognize that sort of thing? Does anyone else have my advanced age? I see some gray hair down there in the audience. Algorithms plus data structures equal programs. Remember that? That was an extremely important book by Niklaus Wirth. No? Doesn't ring a bell? Anyway. This is sort of, if I were to summarize development for AX into one formula, that would be it. So let me summarize a little bit about, at a very high level, what it is. Development takes place in X++. So here I'm talking about the code part. Of course, the main part of development is actually structuring metadata, creating tables, creating forms, all that stuff is done in metadata, but let's focus on the code. The code development takes place in X++, and you can certainly add in C# or VB.NET or F# or whatever you want when you need to do that. And that's one of the benefits of having a new compiler that generates IL code. We'll talk about that. Development takes place now fully within Visual Studio. Those of you who have been in the industry for a while have noticed the progression that we have had from the MorphX environment, which was custom built for this exact thing. And then we sort of added more and more things that you could only do in Visual Studio. And then now everything is in Visual Studio. There is no concept of MorphX anymore, or our own custom thing. Everything is wired into Visual Studio now. It's based on a solid metadata foundation. As you will see as we go along, we have opened up everything. The metadata is there for you to see. It's all granular. You can modify it any way you want. You can look at it. It's not hidden away in a little blob in a database where you can't do anything with it. Everything is open. And you'll find that that's the case for the compiler too when we get there. It's quite interesting. But one of the main advances, and I think if somebody pressed me, I had this discussion before, if somebody pressed me to say what's the most important thing that we have done for AX7, I would say that it's backing it with this Lifecycle Service Management, LCS, that really covers the whole lifecycle service from gathering requirements to implementation to handling bugs to all that stuff. It's all done there for you. That's wired in with source code control. It really makes it very, very easy for you. You don't have to juggle files yourself or use other tools. It's all collected there in one big thing. It's beautiful. Let's talk a little bit about the X++ language. Why? Because I love it. I own it. I am in charge of it. So, you know, if you have a hammer, everything looks like a nail, I suppose. So X++ is this type-safe, object-oriented language. Originally, we patterned it after Pascal. That was our preferred language 15 years ago. And then we put in object-oriented features along the way. It looks a lot like C#, a little bit more like Java. It has a few innovations in there that make it particularly well suited to solving the kind of problems that we want. So note that nobody has ever claimed that X++ is a general purpose programming language. That's not it at all. You can't write a device driver in X++. Well, at least I've never tried, but I don't think that would be a very good idea. It's really focused to working against the metadata and ERP solutions. That's what it's built for. And what we have done is we've built a new set of tools, compiler, debugger, all of that stuff. And I'll show you that in a few minutes. And it generates MSIL code. Yeah, let's see. So it has abstractions for all these things, classes, tables, which classes you'll know from any language, but also stuff like tables, views, which are abstractions over SQL artifacts, queries, extended data types, all that stuff are abstractions that are provided for one purpose, for you to express ERP systems in the most convenient way possible. It also has all the object-oriented programming features like, you know, all these inheritance, polymorphism, all that stuff you know. And that hasn't changed. And notice that even though we did this many years ago, all these features are almost unchanged from what you know from C#. We were successful back then in actually capturing the essence of what object-oriented programming was, to the extent that we could write a new compiler that targeted a completely new stack, MSIL, and still have the same semantics. I mean, that was not a given that that could happen, but it matched very well. And that's the reason we could do this at all without having people rewrite their app. It's a fundamentally healthy thing that we did back then. It has first-class data access, select from, blah, 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 insert record set, all that stuff. And these are really first-class citizens. They're not just strings that you write and then you hope for the best and at runtime something bad will happen if you misspell something. These are first-class citizens where you have full IntelliSense support and all that stuff. Very few languages have that, even today. The closest thing that we have is LINQ, I suppose, in C#. But even LINQ has some problems if you are going to use it for this, because LINQ has interpretation that goes on at runtime, where you look at these trees at runtime through a complicated process to map it to something at the back end. What we have is a very, very simple process that maps directly to SQL statements at the back end. So LINQ is a general purpose mechanism where ours is not. It's a mechanism that works only for this. Now, X++ has a few what we call bleeding edge features. It has extension classes, which are not exactly bleeding edge anymore because C# has the same thing. We patterned our support after what C# does. But we've added something new that even the C# guys don't have yet. And yes, we have a patent for it. It's called class augmentation. It's a feature where you have a class in a base model, and you can have a class in your extended model that really represents the same class, but it has added state and added instance methods and static methods and all that stuff. So from this model here, it appears that this base class here has all these methods over here completely seamlessly. It really is almost magical. Of course it isn't. It's code generation behind the scenes that makes this possible. But it really is quite effective, and I think it's beautiful. We have something coming up which is called type providers. How many of you instinctively know what a type provider is? No? I don't blame you, because we're the first language to implement it. So this is the first time you are, remember this when you're at your next cocktail party, you can stand there and say, I was there when they told you about type providers. You know, and then you can take a sip of your mojito. Type providers are a way where a compiler can auto-generate types for you from a given string that tells you what this class should do. I won't tell you more about it now, but I will certainly write a lot of documentation over the next few months to describe this feature. It's extremely powerful. It takes the concept of object-oriented programming to a completely new level. This was introduced by Don Syme in his wonderful F# language, and we have taken it and used it, and we now have it in X++ as well. It's really cool. Remember it, type providers. You heard it here first. So Visual Studio is the environment that we use, as I told you several times now. We have strong integration. I'll show you probably know all this already, but it knows all about our metadata, about packages and models and the abstractions that we talked about. You can design things through designers. You have IntelliSense colorization, all that good stuff. And the debugger, of course, works. That was relatively easy because the debugger understands natively IL code, so that was not too bad. We can handle error messages and all that. As you dig more into this Visual Studio experience, you will notice that it's very, very open. You can do anything you want. Everything is based on XML files. So if you wanted to, you could do development in Notepad. If you had a lot of patience and a lot of understanding of what went on, you could absolutely do that. I don't recommend that you do, but we don't have any secrets for you anymore. There are no secrets. You can do everything. Everything is opened up for you. You can reason about dependencies of source code because we write a cross-reference database that you can query against to do your own analysis if you want to. The compiler itself is not open source, but it certainly is open. You can write your own tools very, very easily that reason over source code even. Does this ring a bell with any of you? Have you heard this before? With Roslyn? Remember Roslyn? Hands up, Roslyn. How can you have survived this long without knowing about Roslyn? Okay, Roslyn is the same environment for C# where you can actually build models of your language constructs and do analysis over them. And you can do this with a new compiler as well. You can write tools of your own. Even the error messages are XML files. We are enamored with XML files, at least I am. And because they are XML files, you can do anything with them. If you have a large set of errors, which you will when you do upgrades, you typically start with large sets, you can import them into Excel. You can do power pivots over them and slice and dice the error messages in any way you want because it's XML and Excel understands XML. So you know, we have based this on tools that are available and useful and available to anybody to mess around with. So that's part of the power of AX7, is that. There. But it doesn't stop there. How many of you have used the Morphex environment before? A good half, I would say. So that was a very self-contained thing. It had very limited extension features. There was a class called editor_class, where you could add methods with underscores in them, and they would appear in an add-ins menu. Did you know this? And then you could write editor add-ins, and you could do stuff like that. It was very, very crude, very, very primitive. At the same time, there were some APIs that you could, based on a concept called tree nodes, that you could build tools on and so on. But it was really crude. Visual Studio has an enormous amount of extensibility that you can do. And I will actually show you that in a few minutes. Yeah, let's do that. I don't think this has received a lot of focus. Oh God, my machine just... Oh yeah, great. Do you want to reconnect? Yes. Oh, damn it. This will just take a few seconds. In the meantime, if anyone has any questions, now would be a really good time while this boots. And this is not my wife calling, this is two-factor authentication. Let's hope I don't have to do that too often. Sorry about this. With any luck, yes. Number 7, there you go. Okay, so here you have your Visual Studio environment. And this is sort of the archetypical thing that you will see. I will go through this in a little more detail, but I just wanted to show you the add-ins features first so we can get over that. So let's see, we have here the FM setup form. Let's see. Well, let's start with the source code artifacts. Oops. There is a language snippet concept where you can add code snippets in any way you want, and you can choose them from here. So let's say that I wanted to do a while statement, then it would automatically insert code snippets like this. And I'm just mentioning it because it's not a very well-known feature. You can go in here in your tools and your code snippet manager. And you can see that we have these that apply to X++, and you have your snippets and your user snippets. And you can build XML files. If you see the directory that this works with, this directory here, you can put in your code snippets, which are just XML files that describe these snippets, and deploy them, check them in, do whatever you want with them, and it'll all work for X++. So, you know, not something that we have talked a lot about, but it's quite useful. Let's do the Application Explorer, which is our view against the metadata. I put this into modeling. Let's see, what do I want to do? User interface. Oops. So you notice that there's a concept here of add-ins that wake up on a particular node in the designer. And these add-ins are written by you, or can be written by you. They are dependent on the type of node that you're working with. So this is a form. So I have something called form statistics, which is, you know, not very useful maybe, and it's a little crude and so on, but at least you can add your own add-ins that analyzes the metadata of the thing that you're looking at right now. There is also a concept of add-ins, which is a more global concept. On here, there's an add-ins thing. And here you can have some really interesting things. Apply hotfix, create C# perf test from recording. There's a lot of good stuff in here. And these were things that were written by our developers in C# and just put in there. I built one that, unfortunately for network reasons, I can't show you, but where you have a table and you click on it and it'll open up in SQL Server Management Studio with all the things filled in correctly so that you can do queries against those tables. Stuff like this people are adding, and it's a very, very nice environment. Okay, so we will get back to more demos as we get along. So this was Surface there. Okay, so let's talk about the X++ compiler stack. So a new compiler has been written from scratch by my team. It took us 3 years of full-time work. It's not easy building a high-performance modern compiler. But you will say, well, you know, my kid is in college and he wrote a compiler in a semester. What's the big deal? Well, there's a big difference from writing a school compiler to writing a compiler where you have requirements that you have to run the existing code and add features to it while keeping compatibility with the old one, and generating a completely new backend for it. It's not easy to do. It took us 3 years. It powers the compilation of X++, but there's also many other ways that this compiler really works. There's best practices tool, and you all use the best practice tool, right? How many, let me see hands here, how many use the best practice rules? Good. I will not call out names. I will not. But I did see some people who did not put up their hands. You should. We have tools that do an analysis of what constitutes a breaking change so that we don't have to make breaking changes. It's another story we'll talk about a little later. We've built a lot of ad hoc tools to do analysis over source code, and you can too. We have a full extensibility story that allows you to build these tools. Let me show you. There. Come on, come on, come on. All this waiting time. Okay, so if you go in here and do new project, you will have Dynamics AX, and this is your normal project that you would normally start with, right? There is also an add-in, which is how you author the add-ins that I just showed you. So there's a template for that to get you started, so you can immediately start. There's also a video on the net where a developer who developed this will walk you through how to actually build these add-ins. So there is no excuse. You can build these add-ins very easily. Everything is there for you to do that. But even up here, there's a template called Dynamics AX Best Practice Rules. You can run that, and this is what, a 300 or 400 session? I don't know. But anyway, here you have a system that will set up for you. It doesn't do anything very significant. In this case, it'll just check that let's see, that the name of a method does not contain the word Microsoft. I don't know, we had to do something as an example, right? But this will compile and it'll build a best practice rule for you, and you can just wire that in and it just works. So, you know, you can build these tools for yourself to understand source code. It's a very, very powerful concept that I hope you will enjoy and hope you will do something with. Okay, getting back to my Surface. So if you at some point see a process running called XPPC agent, then that's a service that we run in the background to cache metadata to improve the performance of the compiler. You can kill it. It won't hurt killing it. It'll just restart and do that. So the development tools, well. Yeah. So the development tools are here. Let's do first. Okay, this will not win any competitions. But it shows you at least that you have the concept of a main method. Let me make this a startup. Oops. Set a startup object. And then you would be able to run that. I'll do that in a few minutes. But notice that everything is colorized here. You have your full IntelliSense that tells you about the parameter types. You have over here a drop. Let me do a form here. You have these guys up here that people typically miss, and it's a shame because you don't see them that often, but they are really, really very useful. So let me show you here. Up here you see the types. Normally in one file there would be one type, but in forms, for instance, there are nested types, which are the controls and the data sources. So you can use this to go to a particular type immediately. You can also use this to go to the methods of the selected type. let's go back to this guy up here, and let's see that you can use that way of navigation, which is really very quick when you've used it. You can also do interesting things with where is it? Find all references and go to definition. So immediately that will work for you. So all this stuff all these hygiene factors that you would expect from a modern day programming language, it's all there. It's all there. We built a Visual Studio integration package that provides all that goodness for you. So you won't find anything that you don't like there. We even support now the wait. This is the one that I like to use. Come on. Let's hope that it works well for presentation. Otherwise, I'll just set it back. Come on. Ah. Okay, so many people prefer this dark theme. I know I do. It's easier on the eyes for me. But we didn't support it very well before, but we do support it now. So if you like that, does it read reasonably well down there, or do you prefer the other one? What? It's fine? Okay, good. Now, over here we have, let me just turn it off, and then you can go into View, Application Explorer. And this is the Application Explorer that let me go into Classic View, that you know from the old days. We've structured it slightly differently, but it is the AOT that you used to know. And in here you can go in, user interface contains forms, extensions, tiles, menus, all that stuff. Code will contain classes and macros, and in there you can do expansion and you can do all sorts of good stuff. There's some things that people don't know, which is that you can go up here and you can do, let me have something that contains display. Oops, not displo, but display. Do that. And that'll go over and filter everything that contains display. But what if you only wanted it to be something that started with display? Do we have any of those? I don't know. Let's say we wanted something that starts with Gantt. Oh, come on. Find those. But let's say that I only wanted to find those that so there's one here called Gantt Data, and then there's Gantt Data Rec Explosion. But I only really want the one called Gantt Data, so I can do this, for instance. I don't know why it doesn't actually update immediately. It should. So you can use the regular expression terms that you would use normally. So the caret will match the start of the name. The dollar will match the end of the name. You can do dot star. You can do all that stuff that you can do from regular expressions. Here, it's not just names. That can save you a lot of time. If you're looking for something with ledger, I mean, there are thousands of things with ledger. But you can do useful stuff with that. Okay. But the real interesting thing is that you can go in here and you can do model view. And this will only show you the models. I'll go into what packages and models are in a few seconds. So just know that you can structure things in a way where you only see the individual models. And every model has its own little view of what the world looks like here. So you will find it extremely useful to switch between classic view and model view. And in fact, I think you will prefer model view and never really step away from that. Another thing in here, you have your Dynamics AX options. Let me just walk through them. Organize. Here you can do synchronized database on build for newly created objects. So the process of actually taking the fields and all the artifacts for a table and putting them into SQL is a long-running process. And if you find that you always do this and you don't want to wait and you have incremental changes, you can turn it off and only do it when you want. May save you a little bit of time. There is this, which will limit the set of symbols that you can load, which means that the startup time, which has always been a problem for us, can be reduced slightly. You can play around with those features. There's the build, and this is what I wanted to show you. There's a tab here called Run Best Practice Checks. If you turn that off, it will not run your best practices. So that will save you just a little bit of time if you know that you will go back and fix the best practices later. But you can actually turn it off. I don't recommend that you check in code that has best practice violations, obviously. There's a tab here where you can set which best practices are actually run for each individual model. This is a little bit clunky. It's not the greatest user experience, but that's what it is. Okay, so let me go back to this. Okay, so the development environment again. Can you see the, not really, right? Do we have a laser pointer somewhere? I don't see it anywhere. I should have asked you before. Oh, there it is. Oh, I'm sorry. Well, you got some exercise at least. Okay, the development environment here. So let's hope I don't fall over here. So here's your Visual Studio instance, right? And it has all these extensions like the project system, code editor, designers, all that stuff. And it works off of the metadata, the model store, which is expressed through the view that I just showed you, the Application Explorer. There's a metadata API that helps you talk with that. And then when you do debug and run and so on, then you will actually do the deployment over here. That's how that works. When you do a compilation, a build, you will get your model binaries, which are DLLs. You will also get some other things, some metadata files that's needed for reflection at runtime and so on. But the crucial point here is that there is a divide that goes through this picture from here to here. During development, you do not need a running system. You do not need a running system. That was not true in MorphX. In MorphX, you had to have a running system that you could work against, but the development environment here does not require a running system on your box. You can still do development without it. It's only when you do your F9, your run, that it actually needs to communicate with your running system. Let's see, what do I need to... Is there a question? Nope, okay. What else can I talk about here? I'm sorry the colors are not very well chosen. I wonder why they chose that. So let's walk over the concepts a little bit, because this is crucial to what you have been hearing all week. All week people have been talking to you about the models and packages and extensions and overlayering. Is that correct? Is that a fair statement to make? Absolutely fair statement. So let me just go through it really quickly. A model is just a group of elements, metadata and source files, those are what we're talking about, that constitute a distributable solution. So it's a design time concept that you build when you do support for something, some feature that you're doing. That lives in a model, which is its own self-contained unit. And you notice that the AOT, the Application Explorer, was able to focus in and zoom in on a particular model. However, a package, on the other hand, is a compilation unit. That's what gets compiled, is a package. Corresponds to a DLL. It's a deployment thing. It contains one or more models. It can contain one, but it certainly can contain more than that. It contains everything about it contains obviously the models. It also contains some metadata that describes how these models fit together. You can read it as well as I can, I guess. This one, I think the colors are a little bit better. So just to drive this home, right? We have a model here, and there could be any number of models that fit into one package. So there's a 1 to n relationship here. And there's a 1 to n relationship here as well. A model can be made up of any number of AX projects. And then you package them into packages, which is what get compiled. And then there can exist dependencies between these packages. So a particular package can depend on one or more other packages. So the Application Explorer I already showed you. It's organized by, or can be organized by models, and I really think you should do that. They're all organized as I showed you. As a little helpful hint, you will notice that here you have actually the names of the packages that these particular models are part of. Very useful. So I told you many times that everything is open, right? So the packages are all represented by disk files. And there's a particular, I'm just going to go through this and then I'm going to show you. So you have packages and model descriptors. Okay, let me just show you. Oh, you didn't see that. I wish there was a system where it just knew when to switch machines. Anyway, packages on disk, they're all folders in the system. There is no database now that contains the metadata. This is different from anything you've seen before. Does this really scale? Can we really have everything in the file system and read XML? Does that really work, you ask? Right? Yes? Yes. It does work. It scales really well. The stack that reads and understands XML is extremely fast and extremely effective. We can read in and consume metadata with a speed that is far, far greater than reaching out to a database and reaching stuff in there and getting it back. This was one of the things that we discovered very early, and which is the whole basis of the architecture of the new system, is that it's based on XML that we read. I wouldn't have thought this to start up with. I think it was a risky move, but it wasn't. It works really well. It's far better than any database that you can imagine. So there is, this is no longer true, by the way. It's not called C packages anymore. We'll get to that. Underneath the packages, you have models. So there's a folder for each one of those. And then there's model descriptors that contain interesting information. If you want to know about that, just read the slide. But I'm going to go now to actually show you. There. So let's see. So on your root drive, there's something called AOS service. In there, there's a package local directory. In here, you'll see all the packages that I just showed you. Let's take Application Suite. Application Suite contains some interesting stuff, a bin folder that contains all the compiled artifacts in here, as you can see. Contains a descriptor, which I won't cover here, but then it contains folders for each of the models that this package is made up of. So let's take something at random here. And here is where you have one folder for each abstraction that is available to the user. So there's classes, AX class, there's tables, there's EDTs, there's whatever you want. Let's go into the classes. And these XML files describe an individual class. So let me, I should probably do where's the thing where, option. Never mind. These are XML files. They have suppressed the, on this box it suppresses the extensions. But let's just open it. So this is what one of these looks like. I took something with source code in it, and you will notice that these are just XML files. It has an AX class, it has a particular name, and then it has source code tag with a declaration in it, and this is a C data because it contains less than greater than, you have to wrap it in C data. That ends this method. That was a classic. Then we have methods. This is one method called parm name. Here's the source code, and so on. That's all there is to it. Can you write this? Could you write a tool that generated source code just by generating XML files and putting it in the right folder? Absolutely. There's nothing hidden here. It's all open. You can do whatever you want. Wow, interesting. Could you consume metadata with your own tools just by reading the XML files to understand dependencies or whatever you want? Absolutely. We have taken development of AX from the realm of something that few knew how to do to a place where anyone can use tools that are well known in the environment to do useful work. That's basically what we have done in AX7. That's basically the power of the 3 years of hard work that we did. Yeah, go ahead.
Is the source code that's in here, is this just for reference purposes?
No.
Okay, so this is like interpreted when it's, I can change source code.
So what happens here, that's a really good, let me just repeat the question for the recording. The question was, is the source code here for reference for some reason, or is this really the source code? And it is really the source code. So when you edit an when you edit an X++ file, let me go back to my class here. When you see this pvcs class.xpp, this is a ploy made to deceive you. There is no such file. This is a file that exists only for this particular purpose of editing a file. What happens when you do editing and you do save, another tool that we built that understands source code will look at the file and say, oh, this is the class name. These are the methods. The method starts here and ends here. And it'll generate the XML file that you just saw from that. And whenever you double click on something and want to edit it, the reverse process happens. You look at the XML file and you say, okay, so here's the class declaration. Let me put that in here. Okay, let me go, which methods are there? Method 1, method 2, method 3. Let me just paste them in, one after the other. That's what we call stitching and unstitching for historical reasons. But there is no XPP file. Yes, sir?
What happens with indentation?
With?
Indentation?
It all works. So it just works. So we have had in the very early releases, we had a lot of problems with doing this in high fidelity, where you wanted to round trip correctly. You wanted to make sure that what you see is exactly how you left it, right? And we're there now. So it works really seamlessly now, but there is no XPP file. Yes, sir? I will show you. Oops. So here is, these MD files are, MD stands for metadata. So these are not the design time metadata, these are the runtime metadata files. So whenever you do reflection or whenever you do intrinsic functions in X++, you need to know about metadata. If you do class str, for instance, you need to know whether the class exists or not. At runtime, that knowledge is represented by a pre-chewed thing, which is called an MD file that contains the runtime metadata. That's what an MD file is. Let's see if we can open one. Never mind. Never mind. And also, it contains the actual binaries. These are, oops. So this is the main binary for the application suite. If you opened it in fact, why don't I do that? It probably goes too far. Oh, damn it. Okay. Statistics suite. Dynamics, come on. This keyboard is not my greatest. So this will now read the whole of the application suite. And this is a really nerdy tool. But here you will see everything. You can see the actual code that we generated for each of these artifacts. This is the IL code. Let's, okay, it's not, oh, this was just an integer. Let me find something more interesting. Just a static method. I have trouble finding something interesting here. These are all integers. You can go in and you can see what the code looks like. This tool is, I just use that to show you because on this particular box, I don't have other tools, but you can go in there and you can show the code what it would look like in C#, for instance, and you can understand the code and see exactly what code was compiled. This is a little bit nerdy, but you did ask what was in the bin directory. So you asked for it. Okay, any other questions? No? Let's go. Oh, wait. There. You may notice that that there is a concept of net module here. And you may rightfully ask, what is a net module? So the X++ source code that you know is really one big soup of code. There is no namespace concept in X++ that says this lives in this namespace, this lives in the other namespace. So if we didn't do something cheating a little bit with net modules, that would mean that every time you put in a semicolon somewhere, you would have to recompile everything from .NET's perspective. And of course that would be useless. So what we do is we have a system that takes one or very few elements at a time and builds those and puts them into a small concept called a net module. And that net module is, the list of those is what you see there. And DLLs really are just manifests that say this DLL contains these net modules. So it's a very little known concept that assemblies can actually contain net modules, but we live off of that in our environment here. That's what we do. Okay, surface. Okay, model descriptors, never mind. There's a concept of a full build dialog where you can build things. You can say, I want to build this, 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 and this package, and it'll go ahead and do the build for you. There is, yeah. Where did this come in? Okay, there's this package dependencies graph. That's really nice. Oops. Never mind. No, we'll not spend time with that now. But there is a way to look at a model. I'll do it anyway. Oops. With all these buttons up here, something is likely to go wrong. On a particular model, you can do view package dependencies, and you can do both here. And it'll use this thing built into Visual Studio, which is DGML. And it'll actually generate for you a nice little graph that shows you the dependencies between this model and all the other models. And at the top level here, you have the packages. And in the boxes in here are the models. In this case, there's a one-to-one relationship, but that didn't have to be the case. Let's do the application suite. As you can see, that's a slightly more complex picture. You can organize this in all sorts of different ways. And you can zoom in and you can select the dependencies and you can do all sorts of stuff. Anyway, that's just a way of showing the dependencies that exist between individual packages. Yes, sir.
What about cross-references? So can you also include like regular cross-references in X++?
Yes, we have. I will, if I have the time, I'll go through how that works.
But just a small question. All these relations, they are still stored in the database, right?
Yes.
Okay.
Well, database, XML files. Well, no, the cross-reference information that holds between code artifacts is stored in a very easy to consume way in the database. I'll show you. Getting back to my Surface. Here we go. Come on, click. There. Okay, we need now to talk a little bit about customization. We don't have too much time left, so I'll go through this quickly. And this is something that you should know by now. I mean, you have heard this a million times, right? You may have even seen these diagrams before. There is the concept of overlayering and extension. Overlayering is where you tap into an existing DLL. You're making very, very intrusive changes where you have a piece of source code and you say, oh, I would really like to do something in this particular case. So let me dig into the 5th level of while statement in there and the if statement. Oh yeah, this is where I need to do something. And then you modify the code and do something. And then when everything is compiled, you will be in the DLL of that particular package. That's overlayering. On the other hand, in the blue corner, you have extension-based customizations, where you really are not doing any of that. You're building stuff in your own assembly. The original assembly remains constant, or remains the same, and you're just adding extensions to what already exists. And this is the way that we recommend that you do all customization from now on. Is it perfect? No. Will you still have issues where you find it difficult to do without overlayering? Perhaps. But you don't really have a choice if you're trying to do customizations in App Platform and in Foundation. Those two we have locked down so that you cannot do overlayering in them from now on. So it's not a choice. You don't have a choice anymore. You could go edit the XML files and cheat, but you would get in bad shape the next time we made an update, right? Because we run things in the cloud, we can do updates whenever we want. And then you would be screwed again, and then your stuff would not work. And your customer would be there on the phone, and it would not be a pleasant conversation. Okay. Okay. You can also have the hybrid model, but since you're not doing customizations, overlayering anyway, I won't go into that. We do support both for anything which is not Foundation and Platform. You can still do it. But we urge you to write code from now on that is ready for extension. The code that you write today will be extended by somebody going forward. You may want at some point to benefit from the same thing that we're benefiting from with Platform and Foundation, where you will be able to shove in your assemblies seamlessly without forcing people to recompile their code. So please make sure that you design your code in a way where it's extensible. That's why I say that the developers need to understand the life cycle of the code that they're building. You have to build delegates that react to something happening. And they don't have any impact on a running system anyway. If nobody's listening to a delegate, they're almost no ops. So there's no reason not to do this. You have to build your code in that way from now on. You have to think about this. You have to factor it into your design. Also make sure that you only make public what absolutely needs to be public. Because once something is public, guys that depend on you will call that method or that class. And it will be public, and guess what? You will never be able to remove it. That's what we had to do in Foundation and Platform. Whenever something was there that's public, we will never, ever, ever be able to remove it because we don't know if somebody's using it, and we want to be able to just take an old DLL away and put in a new one. And if somebody was calling it and we had removed it, we would not be able to load the assembly and nothing would run. So make sure that you are really, really cognizant of what you make public and what you don't make public, and make anything you can not public. And protect it as well, because if something is protected, somebody will override that method somewhere. So make everything you can private just to make life easy for yourself. Please. And this coincides with modern development and thinking, right? Make sure that you hide your implementation away in private stuff so that you can change it without changing the interface that you show people. Which reminds me, use interfaces. How many of you use interfaces in your code? Not enough, guys. Everybody should use interfaces. Interfaces are very, very powerful abstraction. You should publish your interfaces, not your implementation. Right? Okay. Okay. So going over the pros and cons of overlaying and extension. Well, in overlaying, it's really easy. You can modify anything. So somebody once asked Sri how many extension points there were, and he said, well, there's 7 million lines of source code, so there are 7 million extension points. And that, of course, holds, but may not be a really good idea. You can do anything you want there. You can do, it's very granular, it's intrusive, but it's very granular. You make the code your own, which means, that's one of the cons, that now that it's your own, you have to manage it. So whenever a new thing comes along, you have to rethink what you did. Sometimes our upgrade tool will take care of it for you very easily, and it'll just work. But sometimes you have to redo the thinking because the underlying stuff has changed, and you need to rethink it. It's expensive. Overlaying doesn't work in the cloud. Yeah. And you cannot use overlaying anymore. We've locked it down, so you can't do it anymore in these two models.
The statement that overlaying doesn't work in the cloud, meaning it doesn't physically work, or it will just cause a lot of bad.
The business model does not work very well, is what I meant. So we need to be able to innovate and do stuff on the stuff that we own and still keep you running. And we can't do that if we don't do this lockdown.
So like it physically works, but it will cause like a lot of challenges. So it's better.
Yes. So here's something that tries to explain this in a little more graphics, at least. You have your suite package here, and you have your extension package over there. And there is a concept of plugins as well. We haven't talked much about those, but those are a way to package codes into plugins and at runtime load a particular plugin that will implement, let's say, tax calculations for India would be one plugin, and the system would know where it would run and it would say, okay, I'm running in India, so I'll do this plugin rather than that plugin. Sort of a interesting. How many of you know MEF? Microsoft, that's the thinking that goes behind these plugins, is that. But everything in extension packages really works off of the original without modifying it. So there are delegates here that get fired, and what you do is you implement handlers over here that listen to those delegates. And you can make changes in extensions to metadata, and magic will happen so that that metadata is merged together with the original metadata so that you have a composite view there. And the same thing applies for code. You can do extensions in code where you do extension methods so that you can give a new view of a class. So now, for all intents and purposes for you, this class has additional methods. You cannot go into the private parts of your class. And when people typically see this particular thing, they say, oh no, I really want to be able to add privates and mess with the private parts of this class. But that's exactly not what you want to do. You don't want to do that. You really want not to mess with the implementation details that the developer has packed away for you, exactly for you not to mess with it. So think about what you make public and what you don't, what you make private and not private. Extensions. There's a lot of pros there, much more than cons. You're only compiling changes. Your assemblies are very, very small, which makes it easy to manage. Servicing is really just copying assemblies from one place to the other. The coupling between the original code and the new code is very, very lightweight. In fact, you can revert a system to running exactly as it did before just by deleting an assembly. Then everything will switch back to what it was before. That's powerful. You don't need to recompile. Also, notice the power of, I said that you could just copy the foundation and platform DLLs and the new version would just work. You don't even need to recompile. Think about that for a while. How can that be true? Well, it's true because we have something called binary compatibility. That means that every time we ship something, we make sure that the surface area is exactly the same, so that no dependent assembly will ever call something which is now made not visible or gone. That's very powerful, extremely powerful. But there are some things you need to think about. You cannot easily achieve everything. There are limits to what you can do. And while we have many, many partners who have now transitioned over to this and don't have customizations in platform and foundation, there are still some places where we know that it's tricky to achieve this. So we are working with that. If you find yourself in a situation where you cannot do extensions, we really, really need to know so that we can provide whatever delegates and so on we need to provide. So work with us on this and help us make this a success. As I said, most developers, most shops have done this successfully. And we have had a process of half a year where we've talked to our big partners and made sure that we have the extensibility points they need. So let me go back to my... So up here, when you create yourself a model, you put in some stuff, let's call it Ignite, me, this is a test, you can do next. And here's where the interesting thing comes in. You have a choice here, two options. Either you can create a new package, which is what you need to do for extensions, or you can go ahead and select an existing package that you want to modify. And this one is the default, which is good. And that's what you need to do to create. The next thing we do is we choose what it depends on. Everything depends on platform, so that's always checked for you. Let me do something that's fleet management here, there. And now, let's call it Ignite. No, I don't want that. Never mind. And then with any luck, there, you will have created yourself a project which is based on this as an extension. Now I can go into my fleet management over here. Can't really see much here. What happened to my fleet management? Financial fleet management there. I can open this and I can, let me do something different. Let's take a form, whatever. And here you can create an extension and it'll add it to your project. Let's do that. There. So now you have the extension here that you can work with, and you can create extensions by modifying metadata or modifying code as we've been discussing. So it's really easy to do this from within Visual Studio. So yeah, that's the lowdown on extension. And typically in these you would implement event handlers. I can go through this, but we don't have too much. We only have 10 minutes left. You can implement event handlers, you can modify metadata and so on, and it'll all work when you deploy this package. It's almost magic, but not quite. So I know that some people in the audience here have existing old 2009 solutions and are going into this AX7 space and want a little bit of advice. So I put in a slide about that, which will appear as soon as I press this button. So obviously always extend rather than overlay if you at all can, right? You have to for foundation and platform. Prepare your own code to be extended. It's much easier that way. It's much easier if you use interfaces and delegates to show people where they need to do their work. Remember I said that there's millions of lines of code. Guess what? Many times the people who are looking at the code don't care about your privates. What they want to know is the interface to consume your stuff. Make it easy for them. Make those things public so that they know what to do and document it. So that you don't make everything public so people don't know what to do. Heed the best practice warnings. You know, we put these warnings in there for a reason. These warnings are distilled from a decade of deploying solutions with customers. They are useful. I'm not saying that necessarily any and all best practice is relevant to you. What I am saying is go identify the set of best practice rules that you want in your organization and apply them rigorously. And don't accept check-ins that violate the best practice rules that you have agreed on. It will pay off, I promise you. Your developers will whine for a bit, but then they will understand that there is really good value behind this. Test early, test often, and test automatically. Now, these came from some discussions that I had on the floor in the expo hall where people said that they were doing development but they really weren't doing much testing. Well, I have news for you. You cannot test quality into a product. You can't. What you have to do is you have to have tests as part of your development process from the earliest part until the thing is developed. You cannot have a product and then test it and then find problems and then fix it. It doesn't work. It takes too long, and what ends up happening is that you don't achieve the quality that you want. Instead, what you need to do is you need to have agile teams that write code at the same time as they write the code that's under test. There is no excuse for this. You cannot rely just on functional tests. People have said, well, we have functional tests that we run once we ship a product. What? Doesn't work. Functional tests, if a developer runs the same test 10 times, he won't find a problem that was introduced, even if it was blinking in red right in front of him. You need to write unit tests that run whenever you do a check-in. You need to have a build environment. You need to have the heartbeat of your organization in terms of something that whenever you do a check-in, you have code reviews. How many of you have code reviews in your organization? Well, thank God for that. The guys who don't, you really need to set up a process that does this so that you share the responsibility of checking in code. You need to have a system where you run these tests and check-ins are rejected if they fail to pass all the tests. At one point we had a measurement, I don't know if it's true still, but we had a 1-to-3 ratio of production code and test code. So there was 3 times more, excuse me, 3 times more test code than there was production code. And that's the way you have to do. The story is different now. You're not you're developing mission critical software for your customers and you're charging good money for it. So people will expect high quality, and the only way that you can achieve high quality is by testing and testing and testing and doing code reviews and doing the proper thing. Applying modern engineering best practices to your organization. So, you know, the times when I started many years ago, we started with XAL. We have some people in the room as old as me who remember this. And it was really easy. You had a little system and you had a concept called triggers. And whenever something happened, you had a little trigger and you wrote 2 lines of code and that was it, and you deployed it to your user and everybody was happy. Those times are gone. Now this is a full-fledged development environment with all the abstractions that you need, but it is a little more difficult to use. It's much more powerful, and with power comes responsibility, and you are the guys who are going to make this happen. So I'm sorry if I sound patronizing and so on, but I have seen this many times, and it really does help if you use these best practices in your development cycle. So with that, I will use the last 4.5 minutes to first of all say that you absolutely need to do the evaluations. We need to get better at doing this. So tell us what we can do better. We need to know. And there's a healthy competition between the presenters to know who did the best. So that's always counts. Any questions? Sir?
What is the strategy for layers? Are you going to keep them, or like what's?
Well, layers certainly have lost a lot of their usefulness. Robert, do you want to comment on? No, he's not here. Is that Robert there? No. No, they don't have a lot of importance anymore. We'll keep them, but you don't need them.
Okay. Do you have any plans? So basically, once again, talking about best practice checks and extensions versus overlay.
Yes.
Do you have any plans to actually enforce any additional best practice rules to, you know, like in the past we had this best practice like deviations, whatever. So if I, you know, intentionally would like to keep the code, I would like write this tag that the best practice checks keeps. But do you have anything that's
Yes, we do. There is a concept where there is what we know as an exclusion list, where you can take the error message and you can paste it into this file, and you can even reach it from the IDE. You paste in the error message, and then it'll know from there on. It will not actually warn about that.
Yeah, my question was like, do you also like, you know, throw a best practice error or warning when people overlay instead of extend?
So there was no, we don't do that in general. We put in stuff that did this over time when we did the migration of the platform and foundation. We had a system where we first did warnings, and then we do hard errors. But we don't do that for you. I mean, if you're in your own models doing stuff for application suite or whatever it is, we don't do that. We allow you to do it without any issues.
Because it would be pretty neat to have the like you showed in the Visual Studio like rules in best practice. Like,
Yeah. That's a good point.
to turn on it, and then I will be always confident that people don't overlay without any challenges, without doing like very expensive code.
That is true. That's a good point. Yeah, I'll see if I can do that. Yeah, sir.
Do you have any roadmap how X++ and AX development will look like in the future?
Well, we have a set of incremental changes that we are going to do. We are going to see if we can fit in type providers in a more active role. We have a set of features that we would like to put into X++. Properties is one such feature. We have a few features like that we want to add, but we have to. We're at a point now where we think that the X++ language is adequate for its use. We will add new features to make it even easier, but we don't have the thumb screws on us right now. That there are some features that we need to do to absolutely solve a million problems. We're at a pretty stable state, and yeah, so we will do changes as we go on. And this was the whole reason, I don't know if I said this eloquently enough, but the whole reason why we have X++ is because we want to have this vehicle that we can tweak and that we can do and that we can adapt entirely towards the problem space that you have and that you live with every day. That's the value. That's why we have invested over all these years, having people like me and my team sitting there for years and years and years slaving over building compilers, which you could easily argue would not be normally part of an organization that builds ERP systems. But all the other competitors have the same thing, by the way. They also have their own languages and stacks to absolutely target the things they're doing. So yes, we have things on our roadmap, properties, some other stuff. But we did, you know, in AX7, we added a whole slew of new things. We added vars, var variables, where you don't need to specify the type. We added private, public, and protected members. We added using statements. We added using clauses. We did a ton of changes. And we did this to adapt more closely to .NET, of course. of the expectations that a C# developer has. But we always need to walk a very, very fine line. Because if we did a language feature that was incompatible with something existing, if we changed the semantics of something that was already there, or even worse, the syntax of something, then you would be screaming at us for good reason, because we would have broken your code. And we don't have a license to break your code. We can't do that. We can only add things that don't mess with something that's already there. So that's the tightrope that I, as a language developer, and my team are walking at all times, is to make sure that we don't break something existing. And that's not always easy, as you can imagine. X++ is an enormous, enormous language, and there are little corners everywhere. One thing that just a random example, I know that we've probably passed the time. Yeah. A random example is that we had some of the string functions, substr, which takes, you know what it does, right? And we said, okay, yeah, great, just map that to the .NET thing, right, and we're done. But then we found out that there are a million different cases that people use where they just put very large numbers as a third argument to mean the rest of the string. And .NET breaks on that. It throws an exception when you try to do that. We say, okay, we'll tweak this thing, and then we'll call it. But then there's this other case this fringe case that you have to compensate for at all times. So just the mapping from X++ to C# or to .NET is not always easy. There's always these fringe things that you need to think about. And that makes my job more interesting and harder as well, but more fun. So I hope that answered your question. It was a little roundabout, but I hope I answered it. Any other questions?
What do you would suggest for test automation? So let's say like we have the implementation, I have this 3,000 of test guides that we are trying to adopt and run test automation, but Microsoft is not sharing that tool to kind of like run everything at once as a library, and like running this 3,000 things through Visual Studio, you know, it's kind of pretty pain.
So Visual Studio does have a test environment for you, where you can author unit tests. And that's what we do. It works really well. The criticism that you will have against us here is that we don't ship all the tests that we have. And that was the main part of your criticism, and I agree with you. We could do that, but it's just an enormous effort for us because there is so much of it. And you know, we would be shipping 4 or 5 times the amount of source code that we're shipping today. And I'm not sure that we can handle that. But you have other options. There's this task recorder that you may know of. Everybody know the task recorder? Yeah. You can actually do a task recording and convert it into a unit test. How powerful is that? That's pretty cool, right? And that's one way that you can build your library of tests pretty quickly.
Exactly. And my question was that like we already have that, right? We are trying to adopt it.
Yep.
And I have, let's say, I will have like 2,000 of test guides. And is there any like good tool to run them at once automatically during the business?
Yes, so the question is, can we help you with building this structure that allows you to do the unit tests and do the check-ins and all that stuff? And yes, we certainly can. We have blogs out there that describe how to do this at some length. Joris de Gruyter has some private blogs that explain how to do this. But your point is well taken, that we need probably to do a little bit more here. We need to, in LCS, for instance, to be able to set up these build environments more easily so that you can plug into it and do what we do or something similar. I think that's a fair point. That's an absolutely fair point, yeah. Well, I think we're about done for today. Thank you very much for attending. It's been a pleasure being here. Have a nice Ignite. Thank you.